Hello everyone, in today's video, we are going to just evaluate the another large language model published by Google known as Gemma3, and it's a multimodal large language model. That's the reason I'm very excited to start using it, and it is having a more than 140 language support as well. So if you just go to the Ollama, because I'm going to use the Ollama to learn this, to run this large language model in my local, right? So it is in 4 different sizes: 1 billion, 4 billion, 12 billion, and 27 billion, and it's a lightweight, very lightweight. This is what the Google is claiming, and we're going to run that on my machine where I have a RTX 4060 with 8 GB to see how it performs, right? So let's get into the demo part. And what I have done is I have already downloaded 2 different sizes model, Gemma3 4B means 4 billion and Gemma3 12 billion, right? So the very first model which I'm going to run is the 4 billion one to see how. So the loading time looks great, and if you just see on the right side, the GPU utilization is 3% and memory is 4.8%. So we can ask very simple question, what is Big Bang? And let's see. Okay, so it seems like the response is way faster. Let's break down the Big Bang theory. Okay, so this really looks good. On the right side, the GPU utilization is 96%, so not a concern. GPU memory is 5.1. Inference speed is really fast. So if we evaluate, okay, 4 billion parameter model is more appropriate for our users to build our own application and use cases. And if we evaluate that and if we finalize that, I think RTX 4060 base GPU with 8 GB memory is good enough because the inference speed is very fast, right? Now I can come out from this and let's stop this one and try to run the 12 billion one and see how it works. Okay. So now the loading time is a little bit higher as compared to the 4 billion parameter large language model, which makes sense. Okay, we're gonna ask the same question. What is Big Bang? Now that you can observe the inference speed is a little bit slower. That is again very obvious to happen. Okay, so GPU utilization is 36%. The memory utilization is a little bit higher. Earlier it was 5.1, but now it's 5.6. So this makes sense, right? So this really looks good. So if you want to use this Gemma3 for image analysis and all those stuff, probably you would like to have Misty installed on your machine, right? So once you have a Misty which has a direct integration with the Ollama, so we can see here the Ollama 212 billion parameter one is actually being run here. So I can just, to attach image, you need a vision model to use for the image interpretation. Okay, this makes sense. So if you have a Misty, you can use that. I mean, this video is not meant for the Misty, but if you want me to just come up with a dedicated video for Misty, I can just do that as well. But if we can evaluate this one, so seems like it just got stuck here, but anyways, let's cancel this out and let's try with, please share the code for web server in Python with library fast API for get and post request only. Let's see. Because it seems like, I mean, when I just went to the Gemma website, it seems like it's saying it's having a very good performance, as compared to the other model for mathematics problem, for coding and all those stuff. So, I mean, I would really urge you guys to just go and check, like for the 27 billion. Let's see. I mean, chatbot arena, hello score. You can see that it seems like it is on a second, like after DeepSeekR1, it seems like this 27 billion parameter large language model is far greater than the DeepSeek V3, which is 671 billion parameter. O3 mini, it's performing well with the O3 mini as well. Ollama 3 405 billion parameter is also lesser is not performing as compared to what this Gemma 327 billion large language model is doing. So this really looks good, right? What you can do, I mean, if you really want to evaluate by yourself for all these categories on which, we can see these benchmarking is happening, you can go to the DeepSeek, and just ask, how you can evaluate, any large language model, right? So you can do that. Similarly, you can ask the ChatGPT-o1 mini. And so see, I mean, if you want to evaluate a large language model, you can utilize these large language models to just get all the questions for all the benchmarking categories. Right? And once you have that, then you can start utilizing that. So it seems like this 12 billion one is, the speed is very slow. So let's come out from this and stop this one and just run the 4 billion one and see how it performs from the coding perspective. Yeah, let's see, because it's very fast, right? So it seems like the coding one is really awesome. Okay, seems like it's doing what it's supposed to do. Cool. It's really impressive, right? The kind of small large language model it is, and it's really performing very well. So let's just try to get automated testing layer for this Python code. Okay, please share the automated testing layer for previously shared. Right, so cool. Okay, that's also looks good. So it seems like from a coding perspective also, it's really doing a great job. So we don't need to go for the 12 billion. I think we can stick to the 4 billion. If our requirement is not getting fulfilled, then probably we have to switch to the 12 billion. But 4 billion seems to be doing a good job for me. Cool. So I think I'm really impressed with this Gemma3, because if I just, just go for any other large language model, with the same size, I don't think so. We have this kind of, a very impressive coding response, right? I mean, for example, for 4 billion, we have 3.3, right? So if I can just take this DeepSeekR1 7 billion, let's run this and see if we ask the same question, what happens. 7 billion is require 4.7 GB, right? So ask the same question and see. So it's right in a thinking mode. So it's trying to think. I mean, it's just giving the approach, like, I mean, how it is going to create that. That's really awesome. And this really looks good, but these models are really awesome, right? So if you really need, so it's very easy for you to compare it, right? You can get these responses, you can write the Python program where you can first hit, the Gemma3, and then you can hit the DeepSeekR1 and get the code and just compare it. Again, you can just create a kind of an agent. First it will take the code out from your Gemma3, and then it will take the DeepSeekR1, then compare the responses and see which one is better. And when you are comparing, again, you can take the help of the large language model. So again, it's going to be a multi-agent system for you. So I'm really impressed with Gemma3, and you can also just play with that. Since it's a multi-model, you can just try with images as well by having Misty installed properly. And probably I will just come up with a video for the Misty as well, like, I mean, how we can upload the image where we can use the Gemma3, which is running locally, to just analyze the images. Right, so that's pretty much it, which I wanted to cover in this video. I just wanted to give you the awareness that now we have a Gemma3 with lightweight, and the lesser number of parameters is doing the magic, which for other models with the higher parameters are not able to do it, right? So again, I'm not claiming that, because I just ask for a few questions, and based on that it would be unfair to say that which model is just performing well. So it's completely up to you what kind of use case you have, what kind of solution you are trying to build, and accordingly you can just evaluate these large language model and just decide which one is best choice for you. So if you have any feedback, suggestion, or any improvement you want me to just incorporate in my video, just let me know through the comment section. And if you are learning something very new in AI, please feel free to put that into the comment section, so that the wider audience can also get to know, I mean, what all things are happening around AI, right? So as always, stay healthy and keep learning on new things. And if you really like this video, please share, subscribe this video. Thanks for watching this.